So find 4 on Y, go up to, you were there, go up 2. Across 1. So if you go up 2, you're just going up to 6 on the Y-axis. Yes, essentially that. What about if you were given that? Can I just have a show of hands? You could confidently plot that. Santana, what would be your first step?
Rearrange.
To do what?
Just make the I, like, on the left-hand side, the equals.
So give me what it would be rearranged.
Y minus 2x. Y equals 17 minus 2x.
Okay, and then what would you do?
The gradient minus 2. And y is 17.
Okay, so yeah, so we go to find 17, that would should have been 4. Find 17 on the Y, and then what would you do with the gradient?
Go 2 down, 1 across.
Yes. Okay. And there is, so you don't need to get any of these examples in. Do you think that you can start on the little sheet that I've given you? Yeah. So you crack on. Jack, how are you with that one? Okay, so you crack on with that one as well. I don't think that you're going to need to get all the, it's a waste of time just to get all of the examples in. I think I'll be able to just show you as we go through, and then you'll be able to do them yourself, okay? So we've got 2x plus 1, which is similar to the first one that I gave you when I was asking you the questions. So what you would do is you'd identify the intercept. The y-intercept is positive 1, and the gradient is 2. It's a positive 2. So I'm going to find 1 on the y-axis, and I'm going to come across 1 and up 2. And make a mark. Always do a minimum of 3. Because if you have a brain fart on one of them, they won't line up with this 3. Ellen?
Always across 1.
Always across 1. Unless, there's an example that sort of addresses that. If you get a fractional gradient, it's sometimes easier to look at it a different way. Okay, but yes, because what you want is rise over run. You want the answer to be 2 for this one, because the gradient's 2. To find the gradient, you do rise over run. So and that, we want that to equal 2. The easiest way to do it, so it's 2 up, 1 across. 2 divided by 1 is 2. Okay. So another one, we've got 3x plus 2 now. Mark the y-intercept at 2. Come across 1 and up 3. We're okay with that? Yeah. 0.5 of x. So 0.5. Sometimes people have brain fart. They don't know quite what to do with the decimal. We'd be all right on a grid like this because you can go up a half. It's across 1 and up a half. Okay. However, if you are struggling, if at any point with any numbers you're struggling with them at decimals to try and calculate, sometimes it's worth looking at it as a fraction. Okay. So I want my rise over run to be a half. I've literally said that this is equal to this. So I'm going to go up 1 and across 2 in order to get the accurate half. Okay? So I will mark the 4, I'm just going to show you, on the y-intercept. And because I've got a half as my gradient, rise over run, 1 rise, 2 across, 1 rise, 2 across, 1 rise, 2 across, 1 rise, 2 across. This is going to show you to come across 1 and up a half. That's also fine, okay? But sometimes you might get given 3/4. You might get given 0.75, and it's easier to look at it as a 3 and a 4, okay? Okay? We okay with that? Yeah. too much with that one. Just remembering your negatives, which I think you are okay with. This way. We addressed the way that it's positioned by looking at this one. Okay, so I'm going to